So what is a naive Bayes classification method? It's a classification technique based on Bayes' theorem with assumption of independence among predictors. In simple terms, a naive Bayes classifier assumes a particular feature in a class is unrelated to any other features. For example, a fruit may be considered to be an apple if it's red, round, and about 3 inches in diameter, even if these features depend on each other or they depend on the existence of other features. All these properties independently contribute to the probability that this fruit is an apple. That's why it is known as naive. So the model is easy to build and particularly useful for very large data sets. Along with simplicity, naive Bayes is known to outperform even highly sophisticated classification methods. So Bayes' theorem provides a way of calculating posterior probability. So the equation is looking like this. Suppose we want to calculate the posterior probability of an event happens, say y, given x. So what's the probability of seeing y given x? And this would equal to the probability of x happen given y multiply the probability of y and divided by the probability of x. So in this equation, the first is the posterior probability of a class or y, the target, given a predictor x or attributes. We can have a vector of attributes instead of just one. And py is the prior probability of a class, and px given y is the likelihood, which is the probability of the predictor given class. Px is the prior probability of the predictor. So what is the advantage of using this method? KNN models and decision trees do not make any assumption about the distribution of the underlying data. If we assume the data sets coming from an underlying distribution, we can treat the data as statistical samples. This can reduce the influence of the outliers on our model. So a naive Bayes classifier assumes the independence of the predictors within each class. This classifier is a good choice for relatively simple problems.